Well, thank you, everyone. Bonjour. So I'm Noémie Cavadec. I do CDN performance optimization at Broadpeak, which means I'm in the middle. So I have to adapt to what you guys come up with. Lately, MoQ, which means that we really want to go from what we already have, a pool model, so a bunch of users, a CDN and origins, and go to a push model, where everything is inverted. We still have the same amount of users, same amount of CDN, same infrastructures, but be able to swap from Dash to MoQ. Obviously, because we do have heavy ossification in the users, we need to cater for everyone, so all TVs, mobile devices, a lot of different devices that do not support TLS 1.3 or HTTP 3. So basically, it means that we will need to have what we got plus MoQ at the same time if we want to transition. We can't do one swap and switch to MoQ for what we already have. So we will need to play along and have ABR and MoQ alongside, probably within the same infrastructure. So being a pushed model, MoQ, it means that someone has to push. It does fit very well with CMAF ingest, so it's being pushed right at the beginning and then alongside the chain until the users. But we can also push basically anywhere from the chain. And when we started playing with MoQ last year, a big chicken and egg situation, so no origin to play with, no clients, no relay. And what I really wanted to do is play with MoQ to see if it was going to be a thing. Is it beyond headlines? And for that, we built a half relay. So because we did not have any origins ready, we instead have what we call a half relay, which pulls data from a dash streams and then converts the dash into a MoQ. So we map every layers into a track, and then we build a basic catalog. At that time, no warp, no cap, so basic dash pushed into a track, but now it's fully CMSF compliant. And beyond being a tool, it also has some interesting properties. One of them is we pull the content, the data, the dash the segment, but the one we push in MoQ is the exact same. So the content being pulled and pushed in two different formats is the same, which means that the HTTP cache can also be a MoQ relay without needing additional memory, as long as you use the same packaging. So you could rely on the same packaging pipeline and yet serve two different protocols at the same time, which means that MoQ could be transitioned onto existing infrastructure without needing to buy new servers. Because if you go to a service provider and tell him, well, you need to change everything and also new infrastructure, that's going to be a tough sell. And so that could be a key to transition to MoQ. You don't need the whole chain. You might only need a part of it to convert what we already have and then push MoQ to get what has already been presented, so low latency and so on. So basic mapping, what we've done, I think most of you might be already knowledge with CMSF. So what we did to map the dash segment into MoQ, you got a dash segment full of gaps, one MoQ group, one MoQ object. And that segment in the HTTP cache is still exactly the same one that we pushed to MoQ. So there is only one memory cell being used. And for CDN, cache hit ratio is really key. If your cache hit ratio goes to, well, really bad numbers, that means that the requests are not being aggregated and the origin will die eventually. So that means we could have both of them using the same cache. But when we started playing with it, one hic, we did have some very bad performance issues, which I will get into later on, but to swap, we do need to have the same throughput, right? We already have very large density. We try to push as many clients as we can into a single service. So if we are serving 100,000 clients with 400 gig of goodput, we do need 400 gig of goodput with the same server. It doesn't matter which protocol, right? We don't really care about the envelope, we just want data in, data out. So to highlight what we did to get such results, this is one of the benchmarks we did. So a relay in the middle, 10,000 more clients on the side requesting a track, and one publisher publishing some absurdly large bit rate, so 60 megabits, so basic for KHD or Blu-ray, right? And I'm using Moxygen, so Meta MoQ transport library, draft 14. I've read on the bench just before the presentation. And what do you know? Performance are not up to par. You shouldn't really care about the numbers. They are low, but that's expected. The key is there is a very large discrepancies between what we already have and MoQ at the moment. Bear with me. So 5 stages of grief. At first, denial, right? Why would even anyone bother with MoQ? And then anger. Why do I have to bother with this? And then when I took a look at what was really happening, bargaining. If you take a look at the flame graph, which represents what is my application doing that benchmark, all of that is quick. Because all of that is quick, it also means that none of it is MoQ. And I couldn't even see a single MoQ stick trace within that flame graph. It's not really surprising to us, because to do MoQ, you do have to do HTTP3 first, and we pretty much had the same result with HTTP3. So yes, I am overly skeptical over quick. But because Moxygen was such a low part into the flame graph, I was really interested. So then we move on to evaluating the costs of MoQ, or the envelope of MoQ. Right? We want to get pictures and send them. So we want to really reduce the cost of the envelope, whether it's HTTP or MoQ, to an absolute minimum to fit as many clients as we can per server. So a bit unorthodox benchmark, I'd say, because it's tough to really compare MoQ being subscribed and then the other one being simply pushed and requests. So for MoQ, 10,000 clients per core, same relay, same CPUs, same MoQ stack, and the publisher is pushing 1 byte object every 1 millisecond. So the goal is really to measure how many objects can you send and see in the flame graph what is the cost per object, right? And for HTTP, really basic, do the same, except you do HTTP GET on a single word object that is already in cache. And let's start with the flame graph from the HTTP result. Oh, further result, right? So let's go to the chase. MoQ is actually very powerful, and it's actually very cheap per object, which is allowing us to send a track, basically, of objects, way more than HTTP, because, well, HTTP, you do the request and the response. With MoQ, you only send the data. You only do half the job. So there is a very real possibility of MoQ being high throughput in the near future. For HTTP, well, if you look at the flame graph, yes, it is expensive. Even so more for typical CDN workflow, you need to check every request, validate your token. Does the users have the right to see the content? So it's very expensive to pay for every request and sending a response as well. Yeah, you know, HTTP headers are not cheap, by the way. For MoQ, well, I had to double, triple check the results. I was really flabbergasted about what I was looking at. I can finally see some MoQ, very small, but most of the time it's just my event loop spinning and waiting for events. So it is absolutely cheap. It's really efficient CPU-wise because you got a content and you push it to everyone at the same time. So there is a very close proximity to every response. And CPU-wise, for your cache, it's really wonderful. And so, just to conclude, MoQ, everyone's talking about ultra low latency. I care about performance, which means I hate low latency with a passion. And we do have different kind of bottlenecks in CDNs. Sometimes, yes, we might be network bounds, and QUIC can be used to push as many data as we can through the IP network. But more often than not, we do end up CPU bound, and it's low latency until your CDN is at full capacity, in which case it's going to turn into a slideshow. And being able to choose with MoQ on web transport, being the abstraction, you can choose which one you want, QUIC or HTTP2, basic TCP, so that you can adapt to every bottleneck you end up with. So MoQ can really be a protocol that reunite everything and rule them all way, like he said. So, yeah, no, I'm basically done. I was overly skeptical over MoQ, and I'm a reform hater, and now I'm trying to push it. So.
Thanks very much, Naminoué. Is there any questions there among all your MoQ experts? Or non-experts? Cyril has one, or no? And there's, I saw you, yeah.
Thank you for the presentation, very interesting. A question about the performance of QUIC.
Yeah.
Do you see a path to improving it becoming better, or like hardware encoding, hardware processing?
Well, many things do. TCP is older than me, so lifetime of optimizations. So we will catch on eventually, I think. QUIC does more, so you will still have to pay more. For example, with TLS over TCP, you can encrypt a BFE 60K TLS record and then send it to the kernel, where you will chunk it and paste it. With QUIC, every single packet has to be individual, so you can only encrypt on really small ones. And given that we still use maximum transmit unit stock in the 50s, so 1500 bytes, is still very expensive. But maybe at some times, I still dream of using jumbo frames over open internet. I think at that point, it can catch on very quickly. Plus, there is the fact that, yes, no hardware offload. With TLS, you can really use TLS offload. I've seen a Netflix presentation, and you can really use that with MoQ, with QUIC out of the question for now. So until hardware offload catch on, it's going to be tough.
Very shortly, you have an existing system. You specify something about that, and you would like to add that specific capability. Briefly, you need server client upgrades, you need, and the user does not have HTTP2 yet. So briefly, we can talk after that in more details.
Well, if you want to push MoQ onto every device, we could also use WebSocket, which should be supported by more devices, right? That way you could cater for basically everyone.
Thank you very much.